Hello everyone. So in this video, we are going to see a question that is based on steady state AC analysis. The data is given to you is source voltage is given as 100 sine 40 plus 30 degree, and source current magnitude is 10 ampere, and current flowing through this element is given as 5 at an angle 60. You need to find out the capacitance value C. So let me convert this source voltage into a phasor domain. So I am considering the RMS value. So Vs is simply 100 by root 2 at an angle of 30 degree. Okay, and this is source voltage phasor notation. How to find out the capacitor C, capacitor C capacitance value. So if you see the phasor diagram of this entire circuit, let me call this is my reference axis. So reference axis is basically located, let's say, at 0 degree, is parallel to x-axis, and the source voltage is leading by 30 degree. So my source voltage will lead by 30 degree. This is my Vs. This angle is basically 30 degree, and current flowing through the capacitor, let's say it is IC. This current will lead the Vs by 90 degree. So 90 degree means like this. This is your IC. This particular angle is 90 degree, and the 5 at an angle 60. Let me call this particular current as Ix. Okay, so this current um, will have 60-degree leading, so it will be somewhere here. So this is my Ix, and this angle is 60 degree, so this angle will be 30 degree. Okay, now what is given? The source magnitude current is given as 10 ampere. So if I write KCL at this particular node, from KCL we can write Is phasor is equals to IC phasor plus Ix phasor. Let me show it as phasors. Okay, these are the phasors, and that means summation, phasor summation of IC and Ix is simply Is. So let me um, tell you what will happen here now. So it is 60 degree, right? So this summation, so can say this summation is basically Is. This summation is basically Is. This magnitude is known to us, but we don't know the angle that Is is making with respect to reference, that we have to find out. So basically, we have to do the vector addition, or you can say phasor addition in this case. So I can take one example. Maybe I can derive the formula how to find out the magnitude of two phasor quantity. So let's say this is your reference axis, and one vector or one phasor is located here V1 at an angle of theta 1, and another phasor is located at V2. This is V2, and this angle is theta 2. Let's say this angle is theta 2, and I want to calculate the resultant magnitude. So this angle is simply this one. This is VR, and this angle is, let's say, theta. So VR is the resultant magnitude, and VR is basically V1 plus V2, right? Now, how to calculate the magnitude alone? Uh, Magnitude, if you want to calculate, what are the things is required? Let's say, uh, if you want to calculate magnitude, so if I find out a right angle, let's say, maybe I can erase this theta 1, theta as of now. I'll try to draw the things more clear. Yeah. So this angle was theta 1, right? And this is your V1. So what is the, uh, you can say, x-axis component? This is basically V1 cos theta 1, and this component is coming around v1 sin theta 1. Okay, and this is basically our resultant. We need to find out the resultant magnitude length vr, and if you see this particular angle, this angle, total angle is theta 2, right? And if I, and this particular axis, this axis is parallel to reference axis, so this angle will also be theta 2 because it is parallel. And uh, then what will be the component of, you can say, this small, I can show some another color. So this phasor, this is basically representing V2 phasor. Okay, this particular phasor is also representing the V2 phasor. So if you try to find out the horizontal and vertical components, so this particular value will come V2 cos theta 2. So this particular quantity will come V2 cos theta 2, and this quantity will come V2 sin theta 2. And if you find out the magnitude of the overall picture, the resultant, then maybe I can use this one. Yeah. So if I draw a right angle triangle, let's say this is the right angle triangle. Okay, let's say O, A, and B. This is the right angle triangle, and OB is the length of the resultant phasor, you can say. So you can write VR square is equals to this component. This component is this, but this component is V1 cos theta, V1 cos theta 1 plus this particular length is also, like, this particular length is V2 cos theta 2, V2 cos theta 2 whole square plus this length is V1 sin theta 1, and this length is basically V2 sin theta 2, V2 sin theta 2 whole square. So this is the your magnitude length. So if you find out the overall value, you will get V1 square cos square theta 1 plus V2 square cos square theta 2 plus 2V1 V2 cos theta 1 cos theta 2 plus V1 square sin square theta 1 V2 square sin square theta 2 plus 2V1 V2 sin theta 1 sin theta 2. So from here you will get this one, and this one will make V1 square, this one and this one will make V2 square plus, uh, if you take common V1 V2 from this particular equation, let's say 2V1 V2, 2V1 V2, you will get cos theta 1 cos theta 2 plus sin theta 1 sin theta 2. So this is basically expression of cos theta 1 minus cos theta 2. So the resultant magnitude will come V1 square plus V2 square plus 2V1 V2 cos theta 1 minus theta 2. So this expression will come. Now we will utilize this formula here to calculate the angles and all. So if I just equate the magnitude in both the side, magnitude is given as 10 of the source current, and IS magnitude, sorry, the, you can say, IC magnitude, let's say I wanted to calculate. So IC square plus IX magnitude is known, 5 square plus 2IC, 2 into IC into 5 into cos of angle between IC and IX. Angle between IC and IX, that is, that we have to calculate. So basically this angle was 90 degree. Okay, this angle was 90 degree, and this angle is 30 degree. So this angle is 60 degree. So cos 60. So we can calculate 10 square minus 5 square is equals to IC square plus 10 into cos 60 is half, right? Cos 60 is half. So 5 IC. So if you calculate this value, you will get, let me calculate this one. Hmm. So just a minute. Square minus 5 square square square. So the IC square plus 5C, sorry, um, just a minute. Square minus 5 square, it is coming around minus 75 equal to 0. So if you calculate um, minus 75, you'll get 6.513 and minus 11.513. This value you can neglect negative value because I am considering only magnitude and magnitude cannot be negative. So you can basically neglect this value. So 6.513 is the capacitor current. Now the capacitive reactance XC will be Vs by IC magnitude. Okay. So Vs is 100 root 2 RMS value. IC is 6.513. So here you will get the 100 by root 2 works 6.5 10.85 ohm. So you can calculate 1 by omega c is equal to 10.85. Omega value is 4. So you can calculate c is equals to mm, and 23.026 millifarad. Okay, so this is how you have to proceed with this calculation. So this addition formula, you can it is a very straightforward formula. You can, I think you can remember, and this is how you have to approach. Okay, from the discussion, if you have any doubt, you can ask me in the chat box. Thank you.